Next, we're going to learn how to perform operations with irrational expressions. First of all, let's take a look at multiplication. It's a lot like simplifying. We're going to completely factor it as much as we can and then cancel any common factors. Our first expression has a difference of squares in the denominator, so we'll factor that into conjugates x plus 2 and x minus 2. For our second expression in the numerator, we have t-chart. What multiplies to a -6 and adds to a -1 would be a -3 and a +2. And in our denominator, we're looking for what multiplies to a +9 and adds to a +6. That would be x plus 3 and x plus 3. Because it's multiplication, we do not need to be on the same side of that multiplication sign to cancel. So I can cancel this x plus 3 with an x plus 3 over on the right, and I can cancel the x plus 2 with an x plus 2 over on the right as well. In factored form, my final answer is x minus 3 in the numerator, and I have x minus 2, x plus 3 in the denominator. For our domain restriction, we're going to look at everything that was in the denominator at some point, starting off with our x plus 2 cannot equal 0, so x cannot equal -2. X minus 2 cannot equal 0, so x cannot equal 2. And on the second one, both of those were x plus 3, so we do not need to take care of the domain restrictions separately when we're going to get the same value for both of those sets of binomials. So our domain restriction on this one, x can equal all real numbers except positive or -2 and -3. Finally, we're going to take a look at dividing. Dividing is very much like multiplying, but you need to multiply by the reciprocal. So we're going to factor everything. We're going to multiply by the reciprocal of that second expression, and then we'll cancel. Our first expression in the numerator, we have t-chart again. What multiplies to 1 and adds to -2 would be x minus 1, x minus 1. In the denominator, we have a GCF of x, leaving us with x squared plus 1. That is a sum of squares, so we will not be able to factor that further. Our second expression, we're looking at what multiplies to a -2 and adds to a +1. That would be a +2 and a -1. In the denominator, we've got a common factor again, leaving us with 3x plus 1. Before we cancel, we need to flip that second expression, leaving our first expression alone. And multiplying by the reciprocal of that second expression. The x times 3x plus 1 flips to the numerator, and the x plus 2, x minus 1 flips to the denominator. Now we can cancel our common factors. We have an x minus 1, and our x's cancel as well. This leaves us with x minus 1 times 3x plus 1 in the numerator, all over that x squared plus 1 times x plus 2 in the denominator. Leave this in factored form because the more work you do, the more likely you are to make a mistake somewhere. So if you FOIL these back out, first of all, you're causing more work for yourself, and secondly, you're giving yourself another opportunity to make a mistake. So just leave your answers in factored form. For the domain restriction on this one, we have to look at what was in the denominator before and after we flipped. So we have lots of different pieces to keep track of on this one for our domain restriction. First of all, before we flipped, we had the x and the x squared plus 1 in the denominator on that first expression. From the second expression, we had x, and 3x plus 1 cannot equal 0. After we flipped, we had x plus 2 in the denominator and x minus 1 in the denominator. So all of these expressions we need to set not equal to 0 and solve. First thing I notice is I have two that are the same, x cannot equal 0, and they're already solved, so that will be the first part of my domain restriction, x cannot equal 0. Next, I'm going to solve x squared plus 1 cannot equal 0. Subtracting 1 from both sides, x squared cannot equal 1. Let's think about that for a minute. What number, when you multiply it by itself, equals a negative? It's not possible. So the x squared plus 1 does not give us any domain restrictions. Next, let's solve 3x plus 1 cannot equal 0. Subtracting 1 from both sides and dividing both sides by 3, x cannot equal negative 1/3. We'll add that to our list of domain restrictions. Solving x plus 2 cannot equal 0. Subtracting 2 from both sides, we get x cannot equal negative 2. And finally, solving x minus 1 cannot equal 0. Adding 1 to both sides, we get x cannot equal positive 1. Our list is 4 values that we cannot substitute in for x in our expression because they could at some point make a denominator 0. Finally, I have an error analysis for you. I'm just going to simplify this expression and then we'll take a look at domain restrictions. Starting off, I have common factors of x squared in the numerator and the denominator. So that leaves me with 5x minus 35 all over 3x minus 21. Now I have a GCF in the numerator of 5, leaving me with x minus 7. My GCF in the denominator is 3, leaving me with x minus 7. My x minus 7's cancel. So my simplified expression is 5/3. For my domain restrictions, I had x minus 7 in the denominator. That cannot equal 0, so my domain is x cannot equal 7. I would like you to find and correct any errors you found in that simplifying and domain restriction process, and we'll start class taking a look at that together. And you also have one U-Try question: simplify, divide, and find any domain restrictions.